Hey, how's it going? It's Mr. Riley. I'm going to try to quickly go through the 2.1 notes, hopefully provide some clarity for anybody who's needing a little extra assistance or a little reminder on how some of this stuff works with these parabolas. So, in general, what we're doing is we're talking about parabolas, which is a shape that is formed whenever you graph a quadratic function on a coordinate plane. It's kind of U-shaped or mountain-shaped, and it has some key features. It has a vertex, which is where the turn is in the parabola. So like it goes from going up to going down, or it goes from going down to going up. That lowest point or highest point is known as the vertex. There's an axis of symmetry, which cuts that graph perfectly in half. And then there's some other things that we can talk about later, such as we have x-intercepts and we have y-intercepts. This is where our graph either crosses the x-axis or the y-axis. But right now what we're mainly focused on is the vertex and the axis of symmetry, and we're going to talk a little bit about the y-intercept as well. So here's a bunch of information over here. We have two different ways to write quadratics. We have vertex form, which is a times x minus h squared plus k. In this format, the h and the k are the x and y coordinates of the vertex, and the axis of symmetry is simply x equals h. In standard form, you got a little bit more that you have to do to figure out the axis of symmetry. So you got ax squared plus bx plus c. You have to take your linear coefficient, which is the one that's next to the x, take its opposite, so negative b, then divided by 2a. So that's going to be your quadratic coefficient, the one that's next to the x squared. So whatever this number is next to the x, negative it divided by 2 times this number. So negative b divided by 2a. That also gives you the x value of your vertex. Notice negative b over 2a, negative b over 2a. Those match. Hey, let's look up here. H, x equals h. That x value of your vertex is always equal to the axis of symmetry. Over here, I've got an example problem. My vertex was at 3, 4. I was able to just count 3 and then go up 4. That gave me an x value, and guess what? The axis of symmetry was x equals 3. It's a vertical line that goes through an x-intercept of 3 as well as every other x value of 3. Finally, whether it's standard form or vertex form, if your a is positive, your graph is going to open up. That gives you a minimum point. So if you have your graph opens up, the lowest point is known as the minimum. If you have a negative a value, your graph is going to be reflected and open down. That gives you a high vertex, and that would make it a maximum. So if your graph opens down, you have a maximum and a negative a value. If your graph opens up, you have a minimum and a positive a value. Let's work through a few practice problems, and hopefully those will be beneficial to you as you kind of work through this stuff. So first one, we have an equation in vertex form here. We're going to find the vertex, and we're going to find the axis of symmetry. Just a refresher, this is a times x minus h squared plus k. I can look at this and I can figure out my vertex because my vertex is h comma k. Well, my h value is 4. It's actually positive 4. If I look at this, it says x minus 4. Well, if I look at my formula, it's got that minus in it as well. Something that I say is whenever you're dealing with vertex form, that h with your x is a liar. So if you say a minus 4 here, your vertex is actually at positive 4. So you have an x value at 4. The k does not lie to you, right? It's going to be h comma k. So we have a minus 4. We actually write that as a positive 4. And the k is a plus 2. That's going to stay positive and be 2. So there's our vertex. We just use those two values inside the parentheses and out. By the way, to tell the difference between vertex form and standard form, vertex form has these parentheses typically. Standard form, no parentheses. Just ax squared plus bx plus c. Axis of symmetry. Axis of symmetry is always at x equals h. Well, we just found out that our h value is 4, so this is going to be x equals 4. All right, moving on. Our a value is 3. That's positive, which means our graph is going to, not the best parabola in the world, but our graph is going to open up because our a value is positive, meaning that our vertex is a minimum. All right, what about standard form? A little bit more work involved in this one. I'm actually going to start by finding the axis of symmetry. My axis of symmetry is x equals negative b over 2a. ax squared plus 2x plus c. Negative b over, hold on, ax squared plus bx plus c. All right. Our b value is going to be 4. So in order to solve this, we're going to do x equals negative 4 over 2 times negative 2. Our a value is negative 2. Our b value is a positive 4. So that's what we plug in here. Negative b, negative 4. 2 times a, 2 times negative 2. Now we can simplify that. Negative 4 over negative 4. And that equals 1. So x is 1 is our axis of symmetry, which means my vertex has an x value of 1. Now, to figure out the y value of the vertex, we actually have to take this x value and plug it into the function. If you look up here to find the y value, it's f of negative b over 2a. What that means is you find negative b over 2a, and then you plug it in to function f. So that looks a little something like this. We are going to do f of 1. It's an input of 1. So negative 2 times x squared becomes negative 2 times 1 squared. Plus 4 times x becomes 4 times 1. And then minus 5. And we're just going to order of operations this thing until we get an answer. 1 squared is 1. So I've got negative 2 times 1 plus 4 times 1, which is 4, minus 5. That's going to be negative 2 minus 1. The reason I'm able to do that is because 4 minus 5 is minus 1. Negative 2 times 1 is negative 2. So our final answer here ends up being, this is f of 1, so an input of 1 gets us negative 3. So my y value, awesome, getting interrupted by the announcements here. Another thing, we're going to notice that our a value is negative 2. That means that my graph has been reflected. It opens down because it's a negative a value. So with the negative a value, notice I haven't used a calculator once this entire problem. I don't need to graph this. Because that a value is negative, I know that this opens down, and I know that that means it has a maximum. All right, we're going to do one more problem. We're probably going to get interrupted by the announcements or the bell one more time. But that's okay. We're resilient people. Given a parabola with a vertex of negative 2, negative 3, and passes through negative 5, negative 21, write the equation of the parabola in vertex form. So, vertex form, y equals a times x minus h squared plus k. Guess what? We're given the vertex. That's h and k. We're given an extra point. That could be an example x and an example y. I put that little 1 there, that little hash mark there to indicate that it's an example x and an example y. So I can actually plug these values in to solve for a, because notice, I have y, a, x, minus h, plus k. I don't have a up here. I have h and k, I have x and y, but I don't have a, so I need to solve for a. And what I'm going to do is I'm going to plug in all these values. Y, I'm going to replace with negative 21. A is still unknown. X is negative, x is, negative 5. Minus h, so that's going to be a minus a negative 2 squared, and then plus k, that's going to be plus negative 3. I could have put minus 3 there, but, here we are. Let's do some math. All right, negative 5 minus a negative 2. That's going to be negative 5 plus 2, which is negative 3. That needs to be squared. Still got an a value out here. Still got negative 21 hanging out. I'm going to go ahead and change that to minus 3. Plus a negative 3 is the same thing as minus 3. Negative 3 squared is 9. So I've got a times 9 minus 3 equals negative 21. And we can start to work this out. No more math really to be done on one side of the equation. We're going to have to start moving stuff around. So I'm going to add 3 to both sides. Negative 21 plus 3 is negative 18. That equals a times 9. So what times 9 equals 18? Well, I can divide by 9, or I might just know that that's negative 2. So negative 2 equals A. And here's what we're going to do with that information. Our final answer needs to be kind of a generic equation. It needs to be y equals something. So, with an x in there still. So we're going to go back to our original vertex form. We're going to keep the y. Now we know what A is, and we're going to keep the x. Everything else, that h and k, we're going to plug in. So I'm going to put a plus 2 and then a minus 3. The reason I did plus 2 is because this minus negative 2 is the same thing as plus 2. So I've got my a value, I've got my h value, and I've got my k value plugged in there. With that, I have a final answer. A generic equation that if I were to type it into a calculator would have a vertex at -2, -3, and it would pass through -5, -21. Hope this video was helpful. If you have any questions, come see me in tutoring or ask in class. I'll see you in class.